Okay, let me quickly introduce myself for those of you that don't know me. My name is Mehul Shah. I am currently the general manager of AWS Glue and AWS Lake Formation. These are two web services on the AWS platform. And my brief history prior to this, I was an entrepreneur, a co-founder of a company called Amiato that was doing ETL in the cloud. And then prior to that, I was a database researcher, writing papers and publishing at places like VLDB and Sigmod and so on. Been in the data space all my entire career. And today, what I'm going to share with you is what we see, or what I'm seeing at AWS. What I see is happening in the data warehousing industry and how it's evolving. What we see our customers doing, instead of using data warehouses, they're instead building data lakes, sort of a new paradigm for organizing all your data in your company. And I'll be spending a lot of time today talking about lake formation and how lake formation makes it easier to build data lakes. At the same time, please feel free to ask questions as we go along. I'm going to leave about 15 minutes at the end of this talk to kind of discuss what we see and answer any questions that you have. But feel free to try to keep this interactive. Okay. Okay, great. So quickly, today I'm going to go over four things. First, motivate why our customers are actually building data lakes. Describe to you what we mean by a data lake. Tell you a little bit about why it's hard to build a data lake, and then show you a little bit of or sort of a taste of lake formation and the technology behind lake formation that makes building data lakes much easier than it was before. And we have a lot more to go. And I'll close the talk by talking about some of the key sort of research opportunities that we have in this community to help advance this evolution or revolution that's happening in the data warehousing industry. So you all probably know this because you're attending, VLDB. But about 25, 30 years ago, this is how companies used to organize all of their data. They did all of their decision making based on the data that they had in their enterprise data warehouses. They were building these big analytic databases, and they were feeding these databases with data from a bunch of structured databases, operational databases that recorded their transactions, what was going on with their customers, what was going on with their employees, and so on. They'd get all this data into a centralized place called the Enterprise Data Warehouse through a process called ETL, extract, transform, and load. You'd spend a bunch of time designing a unified schema, maintaining that schema over time. It would take months, but then you'd get your Enterprise Data Warehouse up and running. And once you had it up and running, you'd use business intelligence tools to analyze that data. And for the most part, you do a little bit of ad hoc analysis, a lot of reporting, and this data was feeding decisions that our C-level executives made in organizations to optimize or change the strategy or build new products around their business. Okay. Well, since then, a lot of years have passed and many things have changed. The biggest thing that has changed or evolved is the data. In particular, the data that people want to analyze in their company no longer fits inside of a data warehouse. And here's what I mean by that. First, there's a lot more data that companies are collecting than people think. It turns out, as we kind of look over our customer base, the amount of data that companies are storing is growing about 10x every 5 years. And most of that data is untapped. It's dark. It's not actually put into a data warehouse. And so if you're thinking about, building a data platform in your organization, you're thinking about building a platform once every decade and a half. And so if it's got to live about 15 years, that data platform has to scale 3 orders of magnitude. And that's a long way to go. Okay. And data warehouses are no longer scaling. The data no longer fits. It's too big. And so it's no longer cost effective to put into a data warehouse. The other thing that's happening is that the data is much more diverse. We're not just putting structured data into these databases, but you've got machine data, network logs, social networking feeds, IoT logs, semi-structured data, unstructured data, research articles, and so on. And those things don't actually fit because data warehouses are really designed around structured data. Another pressure that we see in organizations is that it's not just the C-level executives, but there's a lot more people whose job it is to analyze that data. You've got line of business users that want to optimize their products, product managers that want to see what's going on with their customer base. You have DevOps folks that want to do debugging of their distributed applications. You've got business analysts that are looking for opportunities to optimize various aspects of their business. Data scientists that are looking to build predictive models. And the kinds of analyses, as I said, are changing. It's just not SQL analytics anymore, but people want to do machine learning, real-time streaming analyses for fraud detection or event detection, and also scientific analyses. And then the world also around us have changed in the last 25 years because now that there's a lot more data out there, people want to not only do you want to democratize access to that data across your organization, but you also have to comply with a number of regulatory requirements, either from the government, so privacy requirements like GDPR or CCPA that says, hey, you've got to forget, our customers have a right to have all their records deleted from your systems, to other kinds of requirements that are there in the industry like HIPAA, FedRAMP, SOC, and there's hundreds of these that you can go get. And these are at odds with one another in terms of being able to give people access to their data versus making sure that data only gets into the right hands. And so all of these things that people want to do with their data are just not that easy to do with a data warehouse or a collection of data warehouses. And so this is where data lakes, in particular the cloud, and building data lakes on the cloud has come into play. What we see customers do is take all their various data silos, whether it be an operational database, a NoSQL database, a data mart. We see them unblocking a lot of their silos or unlocking a lot of their silos and pouring their data into a centralized storage system, a cloud storage system like Amazon S3. Why? Because it's there. It's ubiquitous, it's low cost, it's cheap, and it's highly durable and highly available. Okay? And so what that means is you actually now have the ability to centralize all of your data assets across your entire organization. Prior to this, you'd have to build your own data center, manage your own file systems and stores and scale them. And at some point, you just didn't have the expertise to do it anymore. Relying on the cloud, now this can actually happen. The other thing that the cloud allows you to do is, pick any engine that you want. You're not stuck with just one data warehouse or one type of data warehouse or one type of analytics. We have, for example, Amazon Redshift, which is our data warehouse in the cloud, Amazon's data warehouse in the cloud. We also have, Amazon Athena for doing SQL analytics over your data lake directly. We have QuickSight for doing BI, business intelligence, SageMaker for ML, EMR for doing big data analysis. And these things can be spun up as you need, as you go. There is no upfront investment that you have to pay for and kind of, maintain over time. And so now the question that arises is, how are you going to actually manage this entire thing on your cloud infrastructure? How are you going to make sure that the right data is accessed by the right people through the right engines? What is that single locus of control going to be? And how are you going to organize all of this so that you can actually, make all that stuff work together? How do you multiplex this data? And that's really what the data lake is about. That's really what, the activities or the things that you have to do to go build a data lake is all about. It's not just about pouring data into a single place. So what is a data lake? It's a new information hub. It's no longer, it's no longer the data, enterprise data warehouse, but it's a new information hub that we see companies building for doing all of their decision making and analytics. It's a centralized, secure repository, and it's important to say secure because of all the government regulations that are out there, and also company regulations that are out there. It allows you to govern, discover, share, and analyze both structured and unstructured data at any scale. And we've got a number of companies, I think more than 10,000 companies building data lakes on AWS, more than anywhere else. And here's sort of a small selection of those companies. And a number of them also are using lake formation to actually build their data lakes on AWS. Now, I don't want this to be just an advertisement for lake formation, but I do want to kind of point out that these companies are getting tremendous value out of lake formation. There are three main things that they're saying. One, it's a one-stop shop for building your data lake. It simplifies your access, your ability to set up access controls for all the data assets in your company. And it makes it super easy to ingest and clean that data. And that's sort of roughly the three things that lake formation does for you. So before I go into and dig deep into lake formation, let me tell you a little bit about what's hard about building data lakes. And I'll tell you about how lake formation makes it easier. So we all know this, cleaning your data takes a lot of time. People talk about this, 80% of the work goes into cleaning. What people don't often talk about is, how hard it is to actually secure your data, which is what we've seen, throughout our ecosystem and our customer base. Here are the typical steps of building a data lake. Each of these steps actually are done by different personas. The first step is in sort of preparing your data so it can actually be analyzed, the ingestion and cleaning phase. You're going to extract data, you're going to set up storage, sort of landing area for your data in S3, and then you're going to go through the hard job of making sure that data is in a form that you can analyze it or build machine learning models or do inference on it. And typically today, data engineers do this work. What we don't often talk about in this community is the amount of work that it takes to actually secure your data. Data stewards are typically responsible for this, and what they're doing is they're deciding what data products are going to be in these data lakes and who's going to be able to access them and how they're going to be able to access them. And what we're finding is that the mechanisms that are out there for securing your data and sharing that data effectively or cost effectively, they're just not really well thought out, and ends up causing a bunch of overhead, both in terms of storage and maintenance. Then the third thing that people want to do with their data lakes is just use it, and this is where the data analysts and the scientists come in. So it's hard to build these data lakes because you actually have to and build a system for making it easy to build data lakes, because you've got to actually serve multiple personas. Let me tell you what it looked like before lake formation. So if you're on AWS, if you were trying to build a data lake, you need to get to your sources. So here's an example of a screenshot of all the sources that somebody has in their account for their databases. These are SQL databases, Postgres databases, MySQL databases, Oracle, and so on. You locate those databases, you got to figure out a place to put the data. So you set up landing areas inside of S3. Now you got to set up access policies on who can access these landing areas. Now you really, the consumer of this data really wants to think about data sets as collections, but the policies and the way you kind of express these things really are focused around the bits and bytes of how you organize these things inside of your object store system. So in this case, it's how you organize it in S3 with an object, and who gets to access a single object, or who gets to access a bucket or a list of buckets. And so they don't map very well or very easily to the collections that you want to think about. Like, here's my database coming from sales, or here's my database that's coming from my IoT devices. And there's all kinds of limitations on how big these policies can get. Then you got to go and actually map all this stuff to some kind of data model. We actually give you a data catalog. Glue is the service that does that. It's one of the services that I manage, and it has a data catalog inside of it. And you can actually create a data model for all the data that's sitting inside of S3 that's based on tables and databases, but you got to create it. And then you got to, build an ETL flow that actually gets the data from one place to another. In this particular case, you're writing Spark scripts. Then you got to also protect your metadata. So you got to create metadata access policies, again, using the same JSON-like language that we had for S3. And then finally, depending on the service you're using to analyze the data, you've got to set up users and access control for the service. In this case, it's a terminal that you're using to access Redshift, which is a data warehouse. And then you got to do this all over again, but depending on the data set, the users that you have, or the end services that you're using. And of course, you're still not getting exactly what you want. The system that we had before was manual, error prone, and time consuming. And so here comes Lake Formation. Okay, it's a fully managed service that allows the three personas that we talked about: data engineers, data stewards, and data analysts, to build clean, secure data lakes in days. Lake Formation is basically, if you will, the locus of control that helps you multiplex all this data that's in S3 to all the various engines that you might want to use to analyze that data. And it offers two main features. One, for simplifying the ingest and cleaning process. Okay, and there, underneath the covers, there's a bunch of different primitives that you can use to make that easier. I'll get into some of those in a second. And then the second big thing is it allows you to secure access to your data in a centralized place, so you don't have to make innumerable copies of your data when you want to share it. And so that allows you to have cost-effective sharing of your data in a secure way, according to your governance and industry policies that you have, compliance policies that you have. At the bottom, of course, is Amazon S3, which is the ubiquitous, low-cost, highly reliable data lake storage system. It gives you 11 nines of durability. All right. Before I get into lake formation, let me just tell you about some use cases, some things that we were able to do with lake formation, and it kind of highlights what the difference is between a data lake and a data warehouse, and why it's so powerful. This is my favorite example. We're all going through this sort of shared experience across the world in this pandemic of trying to fight COVID-19, or at least try to stay away from the disease. A few months ago, we decided in AWS that, even though we're not experts in the disease, we should try to help in some way. And so we put together basically a grassroots efforts, basically on shoestring budget, which is, whoever wanted to help, to put together a data lake that has information, relevant information that scientists, experts, health experts could use to track, contain, and fight the disease. And we sourced a whole bunch of publicly available sources and built a data lake around it. So example data sets that we have in there are Johns Hopkins University's cases and deaths data that you all probably have already heard of and looked at. But we also have a hospital bed availability data, data on research articles on COVID-19, which are growing enormously, exponentially fast. And also data not just from healthcare institutions and nonprofits, but also from universities like Carnegie Mellon that are trying to predict where COVID-19 flare-ups will happen through surveys and other statistical analyses that they're doing. And this is kind of typifies what you would want to try to do with a data lake. That's very hard to do in a warehouse-like environment. So for example, imagine you wanted to see, what kind of therapies were working. Well, there's, I think almost 50 or 40 to 50,000 research articles in this data set that's there by the Allen Institute. And if you're trying to look for a particular, therapy, for example, therapy for inhibiting a certain response, you can actually do a query against all of the metadata that's there, but it's all in this sort of very unstructured form, and all the key concepts haven't been pulled out. What we did is we showed that you could actually use things like Amazon Kendra from our ML team, Amazon Comprehend Medical, to very easily process this data, bring out the keywords, and then run typical BI analysis to kind of pinpoint the articles that are relevant, and then kind of dig in, or just do traditional search through Kendra to find relevant articles and then kind of iterate on it. This is the kind of stuff that's hard to do in a data warehouse, and take something like this and try to make it available to the entire world in a data warehouse, and you realize that it's almost impossible. You can't have. I think we have more than tens of thousands of customers actually using this data lake. You just can't have all of them using a single data warehouse. And so this ability to kind of automatically spin up the engines that they need at the time that they need in this on-demand cloud environment makes all of this possible. And so this really is very fundamentally different from what a data warehouse is. And people will say, isn't this just a modern data warehouse? I think qualitatively it's very different. Okay. And we were, by the way, with lake formation and the ability to kind of securely share this data. And what I mean by securely share this data is that you can get access to this data without having to copy it in many different ways, because this is all public data. We're able to set all this stuff up, make sure that all this curated data actually gets into a single place in a matter of days. All right, it took us literally less than a week to set this up and launch it. Here's another example. This is a company called Newskin. What they wanted to do was just hide PII data. They're a healthcare company from their scientists, so that those scientists could then do a variety of analysis. Rather than go into a bunch of examples here, the main point here is that they were able to reduce their costs by 40%, eliminate the amount of maintenance costs that they have by over 30%. And the advantages kind of go on and on. Let me kind of dig into how lake formation works. Lake formation basically has two stacks of features. One stack of features really are around doing ingestion. So on the left-hand side, it's actually built on AWS Glue, which is our ETL service in the cloud. And then the other stack of features is really around security and cloud, security, search, and sharing and collaboration. Okay. The cool thing is this is all built on Glue, and Glue is serverless. So all the components that you have, you never have to actually spin up a machine. The main components that I think you need to worry about for this talk in Glue are the data catalog, which gives you a centralized place for managing the metadata for your entire data lake. And that's how we're going to actually manage all the security policies on the data lake. And then they're going to be intertwined. That's how we're going to model the data and manage the security policies on the data lake. And then the serverless ETL component that allows you to actually do a lot of the ingest without ever having to configure a machine. I'm going to walk through an example really quickly to show you how all of this stuff works, and for each of the individual personas. So let's start with the data engineer. To get started, a data engineer basically can use these standard blueprints that we have to start ingesting data. The first thing they do is they tell lake formation, where their data lake is going to be or stored or managed in S3. They just basically give us a bunch of permissions to go and manage that area. And then they kick off a blueprint. It's a template, pretty simple. That's what the name implies. And underneath the covers, it sets up a complex workflow. It's a DAG of jobs that allows you to extract the data from a variety of sources and organize it on S3 so that you can run analytics quickly. So this includes things like partitioning, things like organizing all of the metadata into data catalog, and setting up default policies in lake formation on who can access it. And then because all of this stuff is underneath the covers, it's just running inside of Glue. If you don't like what this template creates, you can, of course, go in and customize it. Here's a screenshot of what it looks like if you're trying to bring in data from CloudTrail. CloudTrail is our service that tracks every API call that a particular account makes, and people often analyze their CloudTrail data for security violations, or just to understand how how their users are using their accounts, and keep track of where the usage is going. Anyway, we have a blueprint that allows you to basically bring that data instantly into your data lake. Here's what it looks like underneath the covers, the sort of the myriad of complicated steps that you need to take to get that data in there, all available at the touch of a button. And then, while all this is being set up, data engineers can also use a bunch of different data cleaning transforms that we offer. The data cleaning transform that I want to talk about right now is a data cleaning transform that allows you to do deduplication. And the reason I want to talk about it is, it's not just a bunch of, pipes and bits that we're managing, but we're also giving you state-of-the-art algorithms to allow you to clean data. These are algorithms that we've created internally within AWS, internally for Amazon retail, that scale better than anything that's out there in state-of-the-art. So the algorithm that I have that I want to talk about today is find matches, that allows you to do deduplication across two large data sets. Imagine, for example, you're trying to merge two catalogs here. In this particular case, these are catalogs of shoes. As we all know, catalogs, they all have various sort of structured attributes like name and price and so on, but the values in them can vary and differ. And in this particular case, we're looking at two different shoes from the same company, and it's actually the same model. It's a saddler, but they're named differently in these two different catalogs. They have similar profile in terms of price. They have similar profile in terms of the number of colors that are supported here. And so you and I can look at this and say it's the same shoe. But if you try to encode this in an ETL process, you might get it right the first time. But if you ever had to evolve it, it would be very brittle, and the set of rules that you create, would be really hard to maintain. And so this is sort of, a perfect candidate for doing ML. And there's a bunch of people that have gone out there and said, hey, look, we can run deep learning on this, or we can use, a variety of ML models to go do this. It turns out none of them actually scaled. Okay. And the reason they don't all scale is because, at the end of the day, our customers want to come in and, they want to do deduplication across billions of rows. For example, healthcare records, or, quotes from various equities and so on. And to do that, the naive approach here is you're going to look at every pair of records, and that's just not going to work. And if you build one of these neural network models, it just takes too long. So we've actually broken this process up into sort of three different steps. And so it's actually standard in the literature. 3 steps called blocking, scoring, and partitioning. And we have innovations in each one of these steps. The blocking step basically says, create subsets of these records that you're going to consider all pairs of, and don't worry about pairs of records across blocks because they're unlikely to match. And then what you're doing here is actually looking for records that match, that are approximately the same. Right? You might do this for record linking. You might do this for deduplication. Then you're going to come up with some kind of scoring function. In this case, we're going to create a scoring function based on positive and negative examples. And then we're going to use a new sort of thresholding technique to partition these scored pairs into groups, and those groups are going to be the ones that are going to be labeled as duplicates or matches. I'm going to save you the details on the algorithm. I think you can read it in the paper. We published it in 2018. The important point here is that we can scale this algorithm to over a billion rows. At that time, it was 400 million rows. Finish it in about 2.5 hours in the previous state of the art, and it took weeks. And the partitioning technique that we're using not only gives you two like an actual score and confidence in how good your grouping is. But it's actually pretty effective without actually, introducing a lot of tuning knobs compared to the previous state of the art. Okay, so that's the work around ingest and cleaning. There's a whole bunch of stuff that we've done to make it simple for people to share their data and share it securely. The approach that we take is you model your data in the data catalog as a collection of tables inside of databases, and tables are consists of columns, semi-structured data, columns, and rows. And then you specify access control policies on that. An administrator is going to come in and actually specify those policies. Users are going to access this data not directly, but through a variety of integrated services. We support Athena, which is a query service, Redshift, a data warehouse, EMR, a big data service, Glue, ETL, QuickSight, BI, and we're adding more and more services over time. They access the data by querying that data through these analytic services, and then Lake Formation basically mediates the access to the underlying data. And we actually have today a shared responsibility model where the engine actually participates in the security, in the process of securing that data. Let me first tell you about the kinds of features that we have in our security. So not only can you control data access on individual tables, rather than thinking about individual objects, S3 objects and buckets, but you also can control permissions on a per column basis. So you might have, for example, products and their reviews, and you might want to give user 1, for example, access to the reviews, and user 2 only access to the columns that talk about the product. So in Lake Formation, you can come up with any combination of these things for any combination of users. The other nice thing about Lake Formation is because all these accesses go through a single access point, meaning they're all going through a single set of APIs. For single set of APIs, a single set of APIs where you get access to the credentials for accessing that data. We know who is accessing what and when. And so you can audit all of the accesses for all the stuff in all the data lakes that you have in your account. Okay. It's also easy to see, who has permission to what, because these permissions are not spread across many different engines. So here's how it works. And so this is the piece that I was stumbling over in the previous slide. You have a user, and typically the user is represented by an IAM role, but you can also have third-party identities coming in from identity providers like Active Directory. They're going to query a table T somehow, and the integrated services are going to know that this user wants to go and analyze this table T. The service on behalf of the user is going to request access for the underlying objects, like the actual S3 files that comprise that table. Lake Formation is only going to give back temporary credentials. These are just permissions to be able to access that data. And these are temporary. They're scoped in time and location so that it's only for the duration of the query. And then those credentials are used by these engines to request those objects. And then the engines are actually going to do the various filtering that you need to drop the columns that are necessary, and then do the computation and return the results. Okay. So the security is actually shared by the integrated service, as well as the underlying data store, which is S3. And this is unique in the sense that we don't have an intermediate filtering fleet. There's advantages and disadvantages of this, and we can talk about it. But one of the advantages of this is, of course, cost. Customers aren't really spending a tremendous amount more money over the normal processing of your data, and this is what they like. So here's some screens. I'm running out of time, so I'm going to quickly go over these screens, but here's some screens on how you can actually use Lake Formation to specify the permissions. These permissions look like standard grant and revoke permissions that you see in a database. You can do it at the column level. And then depending on the analyst and what they're able to see, what these screens are actually showing you is that one analyst is able to see a fraction of the columns. In this case, there are, if you look on the screenshot on the left-hand side, there are 7 columns that this analyst can see. And there's another analyst that's going to access it through a different engine, might see fewer columns. And then the data scientist can access it through notebooks and see all the columns, for example. except for PII data. You can also, through our console, monitor all the use of that data lake, who's accessing what with all the metadata. So you have a centralized place for all your audit logs. So if you have a compliance officer coming in and saying, hey, who accessed what in the past, in the past month or in the past year, you can actually give them a compliance audit rather than trying to, create this manually yourself. And the other cool thing about this, and this is the piece that I think I want to, kind of spend a little time on, is once you get into the data lake world, it's no longer about, a closed world, where you're sitting inside of a data warehouse. In some ways, you suddenly have an open world where you're sharing this data with not just people that within your organization, but you could possibly share this data with other organizations, folks that you may or may not trust with with varying levels of trust. So we recently, for example, released cross-account sharing. So we have customers sharing data that are coming from different companies through S3 without making a copy of that data. Or should I say, they eventually make copies, but at least for the sharing purposes, you don't have to make a copy. Okay. And the cool thing is that the database model for doing security, grants, and revokes is really nice. It's a declarative model. And that declarative model allows you to do things like delegate access. So you can give it to, you can delegate access to a table to some other account, and that account can then further delegate access to users inside of their account. And that model just sort of naturally works. It's what people want. And it was just harder to do in a lot of the other security models that were out there. And so this is, I think, a win for the database community. We kind of figured it out and got it right, and it seems to scale beyond just data warehouses and databases. It's worth thinking about because you can set up all kinds of interesting topologies here. There are many more features here that make it easier for people to discover data and provide context around data. And in particular, in lake formation, you can add metadata that makes it easier to understand what fields mean, what database tables are for. And eventually, you can imagine using these tags, if you will, to automatically secure your data. And so that puts me into the sort of last slide of the talk, which is where does this all taking us? Everybody's building data lakes. We're just kind of following our nose here in AWS. And what at least I did, and as part of our journey here, is back into this. And by the way, all of this stuff is not me building this. It's really the work of hundreds and hundreds of people in AWS doing it. But in terms of the topic, and my interests, I just kind of backed into it, going from data warehousing to data lakes. And it's actually just it's not just a matter of an architectural change, right? It's really a change in terms of what's possible. Okay. And so the data warehousing industry is now today undergoing an upheaval. Customers don't want to be limited by data warehouses. And so we came up with a new name for it, data lakes. It might be called something else in the future, but at the end of the day, it's about managing all your data sets in a way where you have centralized locus of control. Doesn't necessarily have to be in a centralized location, but that's just practically useful in some cases. But you have a centralized locus of control. And the question is, how do you want to enable people to share their data? And this is becoming more and more important in many, many different circumstances. And the two areas where we've started exploring, I think there's a lot of opportunity for researchers in this community to come in and help and define, what's going to happen in this evolution or in this revolution. The two areas that I specifically kind of pointed out is one is machine learning. Now, of course, this machine learning isn't something that we came up with here, right? I mean, for the last 10 years, it's been undergoing a revolution. But this combination of machine learning to help you manage data, not for the sake of actually learning from data, but just for the sake of managing data, I think is incredibly powerful and has a lot of applications. For example, what do you do if you want to be able to automatically, or a lot of our customers say, hey, I want you to automatically detect sensitive data and secure it. Well, that's great, but what if the learning algorithm doesn't do a good job? In many cases, if it didn't do a good job, okay, you call it precision recall error and you move on, and you improve the algorithm. In this particular case, if it didn't do a good job, it could mean a leak of some valuable information. So, so is machine learning even applicable in this context? Because certainly our customers want it. People want to use machine learning to help machine learning. They want to use machine learning to assess the quality of their data so they can build better models and know when to, rebuild their models because the data has drifted. They want to use machine learning to help build ETL flows. Here's what my data ought to look like. Here's what the source looks like. Can you do goal-directed auto cleaning and transformation for me? I'm just kind of, hitting the tip of the iceberg here on some of the topics that we see from our customers. Then there's a whole bunch of, interesting possibilities that show up around sharing, security, and governance. Today, I think we have a tremendous amount of tools to secure our data, to lock it down, to encrypt it, to hide it, to tokenize it. Okay, those things that are there. But what if I want to actually share that data in a limited way? And we don't even have actually vocabulary to even talk about it. But we see this coming up over and over again. For example, all of these people that want to share data about COVID and its impact or its potential impact based on what they've gotten from surveys or healthcare studies that they've done. They want to share this data without actually revealing the identities of users. And we don't have a good set of mechanisms to sort of universally talk about this. And I think those things are going to show up in the next 10 years. Then there's this question around public data lakes. Imagine you have a public data lake and you have hundreds. Like today, we have hundreds of sources. And what if we get to thousands or tens of thousands of sources in our public data lake? How do people find the relevant sources and use them? And then finally, an interesting problem that seemed to kind of tip our fancy a little bit, it sort of came out of this process is, imagine you're actually, doing all of this data sharing and somebody comes in and says, prove to me that that's your data or prove to me that it's not your data, meaning that it actually came from, some public source and you didn't, make any derivations of it. I don't think we have good mechanisms to even talk about this and make those proofs. I just kind of made up a word for it or a term for it called provable provenance. But I think these are the kinds of things that our customers are going to ask for in the future. And I would much rather be prepared with a vocabulary for doing these kinds of things instead of, just kind of figuring it out on the fly. So this is where I think, people like yourselves in the VLDB community can come, collaborate with us, and help us out. With that said, I've taken too much of your time. I went a few more minutes than I wanted to. But thank you for listening. And I am happy to take questions.